Okay, join audio wasn't selected. Now you should be able to hear me. Okay, and everyone can see me okay. How about video? Sounds clear. We get all no video. Okay, 1 second here. Can see the screen share, yeah, right. But for to see me in the corner, you'd have to kind of see the full screen, I think. Yeah. If you want to see, you don't really need to see me, to be honest with you. But hope you like my background. You guys are out of this world. Guys and gals are out of this world. I'm somewhere above the earth getting data. So the main thing is that you see, hey, Houston, we have some problems. No, we have no problems. We're doing okay. So Hamza, hi. So I hope everything's been moving along very nicely for this session. So I'm glad to jump back in here and help out with everything. Hey, Ronald. Yeah, you got to go. You got to exit full screen usually to see me. I'm just sharing the presentation, but no worries. As long as you can see the presentation, that's the big thing here. So I hope everyone's on a scale of 1 to 10. How excited are you to learn about databases? So some of you may have some experience with database. Some of you may not have any. We're gonna. All right, Goose is excited. So databases can be a little dry, but we're gonna try to make it interesting as possible, because it is the factor that makes up a lot of software, right? You can't have software, you can't have applications without data, right? So it's very important. But yeah, but that's okay if you have no experience. This lesson is an introduction to the theory. So you're right where you need to be, and I'm going to go slow and try not to go too fast, even if I get excited about some SQL queries. But you see our usual here, usual crowd. Got Mr. Excited here in the background, getting ready. Mr. Sleepy over here. And then you got the guy looking kind of not so excited on the stairs. So got the usual crowd ready. Someday they'll change. They might shift seats or something. I'm not really in space, unfortunately. It'd be nice if I was in the space station, right? I'm broadcasting live from the International Space Station. So for any of you that don't know me, this is my current LinkedIn profile. If you go, if you friend me, you get a picture there, but of course you know what I look like, so you really don't need a picture. But I've got over 10 years experience, about 11 years experience now, testing in QA, doing a lot of different variety of testing. You can see the most recent jobs here. I've worked in the automotive industry, and I've also worked in real estate data, but I've also worked in the aeronautical networks, which is like networks for airplanes. If you ever fly on like the big planes and you have to get on the websites and things like that, I used to test for that and done a lot of different things. And I can assure you, I've definitely used database testing in my experience, right? So let's talk a bit about our agenda, introduction, right? We're going to have some introduction to databases, right? We're going to learn, you may have an idea what data is, but what are databases, right? Where is this data stored? Okay, then we're going to talk about SQL. Some people say SQL, but you could say SQL. We're going to have an introduction into that, so it's not going to be any really extensive queries. We're just going to kind of cover the basics so you understand it, and we'll talk about your homework. And of course, we'll always have time for Q&A. I'm going to try to go at a steady pace, and I'll have breaks and pauses if I think people don't understand what's going on. But unfortunately, I can't ask every single question as it comes through. So please don't think I'm ignoring you or anything. I'm in space. What am I supposed to do, right? So here we have, this is a little touchy, the screen, but data, right, can be related to anything. Data can be, it's an attribute of what you are, right? For example, I have a name, I have an age, I have a height, and I definitely have a weight. A lot of different things, right? Eye color. There's different things that describe who we are, right? So much like that, a picture, image, a file, anything that describes something can also be considered data, right? Anything that is a way to describe something, right? Can be considered data. There's multiple streams of data, but everything we get into in the internet is definitely data, right? So going to the next slide here. What is a database? Okay. Well, it's a collection of data, right? It's like a folder. I don't know if I'm sure if some of you had the filing cabinets in the past, right, where you have all your tax records. You may have your birth certificates. You may have pictures, right? You have a collection of items, right? So the database is nothing more than that. A digital. Think of it as a digital filing cabinet, right? In fact, they say previously a file system was used to save data, right? So it's very similar. But data is organized in a format that's very easy to manipulate, right? That means you can update it, you can change it, you can add it, you can delete it, you can edit it, right? Well, for all these databases, you have to have a way to communicate, right? And that's what we call SQL or SQL. It's used to communicate. It's a language to speak to the database. Okay. Now, with all that data and all those queries, right, there has to be some way to manage it all, right? So an application is a database management system. Like there's a way to gather all that data and communicate with it, right? So as we progress here, what is a database management system? Well, it's a software, right? It's what you use to communicate. You can also create, manage databases. You can with that database system, the user can actually get update, right? Someone has access to that database, or a developer, right? They can manage data in a systematic way. So all these websites that you use, depending on what you're doing, there's a database behind them, believe it or not. So you're actually editing and updating as you make changes on the website. It's going back to the database, right? So the system that they use here is a way for those to interface between you, the user, and that database, right? Now, if you're working as an admin, you'll have direct access to this. See in the screenshot here. So if you're just a user, you're kind of down here at the. Oops, sorry, slide went. You're down here at the API level, right? That's communicating with the database. You're just the iPad or a computer. You're making changes that travel up, and the database system still has to handle it, right, before it gets to the database. But if you're a database administrator, someone who handles it, you don't have to really worry about the front end users. You're just right here at the management system, right? So you want to make sure that it's easily accessible, that it makes sense, right? That's organized, just like a file cabinet, right? If you have stuff shoved everywhere, you don't have folders, you have papers everywhere. And I'm not saying that's like my file cabinet. I'm just saying as an example, right? You could have out of order, right? It's going to be tough to find things, right? I think I found a Snickers bar in mine the other day, but it was a bonus. So some popular databases, some management systems, Microsoft SQL Server is one, right? There's Oracle database. Oracle, I mean, most people know about Oracle, right? They're the big database kings of data, right? They started out quite a few years ago handling data, and have grown since then. And this one is MySQL, right? They want to distinguish the Dolphin people want to distinguish themselves from SQL. So they say MySQL, right? You don't tell us SQL, you tell us MySQL. And there's Postgre, as you could say SQL here. He's the elephant. They're okay with that. So there's some relational database management systems. There's more, believe it or not, there's quite a few more, but those are some big ones. Okay, and then there's what we call object-oriented databases like MongoDB, Cassandra. They're just necessarily they're still databases, right? There's still data involved, but the thing with those is there's not much relation involved with the tables. You don't have as many restrictions as you do with a relational database. So a relational database would be a little bit more for a smaller to medium-sized company, right? Where you can really get away with that. Whereas if you get into like thousands and thousands of thousands of files of data, right? You're going to need something like MongoDB or Cassandra to handle it. And Tony Smith mentioned IBM. IBM is definitely a player. I'm not sure what product they have now, but they definitely are a player in the database field. All right, so SQL, right? SQL type databases they're primarily called RDBMS, but you're more likely to hear relational databases, right? They have a relation, they're connected to each other, they're family. SQL databases, they're table based, okay? Meaning that they use a table to store the information, a virtual table, right? There's kind of like an Excel spreadsheet is a table of data, right? SQL is used to communicate with that relational database, and that's just the structured query language, okay? So now you learned something new right now. What again, it stands for structured query language, right? That's how you're communicating with the database. Now, a non-SQL or no SQL database is a non-relational DMS database that doesn't, so like I said, doesn't require a fixed schema. There's no joins, there's no joining of tables, right? But it's easy, and you'll learn about joins later. We'll talk about what those are, but it's easy to scale. That's the most important thing. So companies like, for example, real estate data companies, they have a lot of data, right? A lot of houses on the market, a lot of addresses, a lot of things. They would need something like Cassandra or Mongo, right, to really gather that data. Now, they're primarily called non-relational distributed data or distributed database. Now we won't work too much with them here in this class because we're kind of focused on the SQL because we're looking at small and medium-sized companies, right? But in the future you may see those. But they can be document-based. They can be key value pairs, means that there's a match there in the keys. They can be graph database, something like called GraphQL, which you'll hear in the field. So NoSQL should be used only, I would say, when traditional relational model is not enough. You should always try to use that table, that system, that relational that can be a little easier to use before you jump onto that. But it could be that your company's already working with something like that. So, but that's typically when you would see something like that. Now, just a little bit of a different examples here. You would say select all from table name, right? In SQL database, you have a table to work with where something like Cassandra, you would use db.getCollection. What is my collection name? .find, and you have to put the little brackets in there. So it's a little bit similar, right? But it's a little bit different how it gathers the data, right? You need to tell it specifically what the collection name you're looking for is, right? And then what do you want to do when you find that collection? So it's what we call dot notation. You do like db.getCollection. What's the collection name? .find, and you can even have more dots, right? Have a lot of dots going on there, but typically it's stored a little differently here. Whereas a table, you just have the table name, right? So that's kind of a little difference between the two. And today we'll just go on the website for databases, but later on you'll see how that functions with an actual database when we do some practice on Thursday. So SQL should be pronounced SQL. It stands for, as I said, repeat, structured query language, not unstructured query language, but structured, organized query language, right? There's a structure to it. SQL is used to communicate with the database, right? Well, it's a standard. So that's the key word there. Remember, it's standard computer language for relational databases, right? And data manipulation. Okay, it's used to query, insert, you can manipulate, change data, right? You do that with a query. You say, hey, database, you talk it to it. You say, this is what I want to do. I want to show me this person, this first name, this last name with this data, right? That's how you talk to the database, how your computer talks, right? If you're talking to the database, you might have some other things going on, but you want to make sure to type the queries in to get to it. Now, SQL lets you access that, right? It gives you access. Now, it became a standard back in 1986, so quite a few years ago. But it was a standard developed by ANSI, ANSI, and also ISO. ISO is a big engineering firm, right? So around that same time, they really standardize it. Why do you need standards? Because if everybody had different languages and different things, the database wouldn't work, right? There's a lot of conflicts that would show up. Well, what can SQL do? And Mr. Incredible here will show you it can execute queries against the database, right? You can actually search. And what does query mean? So you may have heard it before, but query is just a search, right? You can search against a database. It can retrieve data from a database, so it can get. Sometimes we'll say fetch, right? SQL can insert records in a database, right? So you can add records. You can definitely update. Some people like to say edit, right? You can edit records in a database. But guess what? You can also delete records from a database. So that's something you only do when you know you want to remove data, right? And it's been removed. Like say somebody gets removed from a email subscription list, right? You want them removed from your database, right? So that's not going to be you. You're not going to be bored there looking at a computer. That's just an example of what too much database querying can do, right? This guy looks a little more happy. Can't see his face because he's looking at the screen, but he's cheerful. What can SQL do? Well, beyond what we said, right? It can create new databases. But how do you do that? You create new tables in a database. It can create stored procedures in a database. You can create views in a database, right? I just want to show you something like first name, last name, salary, maybe if you work for HR, right? I don't want you to see anything beyond that. You just have a certain view into the database, right? You can set permissions on tables. So maybe you only want a certain person reading the data, would be called read only. They can't make any changes. Or maybe you want to give some people changes to a certain degree, right? Certain procedures that can be added. So it's kind of like an admin. And it is an admin. You can actually control what people can see. The database administrator or the company would set those policies. Moving on to slide 16. A relational database, right, is one or more objects, right, and they're called tables. They're called tables. It's stored in these tables. The data actually exist in those tables. A database table, like I mentioned, kind of Excel, like a grid, right? It forms data into rows and columns. So you have information, you have the attributes going this way, and then you have columns, right, for every single attribute. So you might have well, you'll see some examples here later on, but that's primarily how they're stored as tables in SQL. Here's some examples. Come on, slide. It's in the middle. Got stuck in the matrix. Okay, SQL database table. So here's an example. So they're worksheets like I mentioned Excel. The rows run horizontally. Horizontally means left to right, vertically up and down. So think mountain is vertical, right? Going straight up. Horizontal is like a lake, right? Up, left to right, flat. Okay, so those horizontal things represent each record, and vertically represents a specific field or an attribute, right? Now this intersection is called a cell, much like in Excel, hence the word cell in the table, right? Fields in a database is the easiest, simplest unit. For example, here we have first name, last name. So you're going to have multiple first names, right? You're going to have Homer, Peter, Stewie, Brian. I think someone's a cartoon fan here, right? Last name. So you could have multiple Griffins, right? You could have multiple Simpsons. There's only one Kramer, right? But you could have multiple Fries, multiple Wongs, depending on that. But you'd store that last name, and the date created would be probably unique, right? Unless you created exactly at the same time. But if there's a method, you're going to have date created. And also you can have that customer ID. Well, guess what? That customer ID is going to be a unique field, and we'll learn more about why that's important because you want to have a way to uniquely identify Peter Griffin from Stewie Griffin, right? It's not always the odd shaped head. It's the numbers in the database. Okay. So again, query is a request. You're requesting, you're searching for that data and you're retrieving that data. So moving on. Okay, so this might be hard to see but it's a logical container for a database. This is what we call a schema. Have you heard the word schematics before? Show me your schematics. Show me your blueprint. Well, it's a skeleton of your entire database. In this case, we're probably looking at like an internet. We're looking at a movie database. Okay, so this defines how the how the software is organized. Okay, so in this case, you have a lot of you have movies and TV shows, right? Well, movies, you're gonna have all the stuff here, like your title. You're gonna have your ID summary, right? That's a blob. Like you'll learn what a blob is, or a blurb if you've ever heard that before. It's just like a collection of characters, right? Because you want to have more than like so many. You want to have paragraphs, so they call it blob. You're gonna have your release date, right? But also beyond the movie, you're gonna have movie people, right? Who's the director? Who's the writer? What seasons and episodes are they if it's a TV show, right? So those movie people might be in TV shows, right? Because sometimes they work on TV series. That person can extend up. You'll learn about. We don't talk too much about the relational tables here, but the way these are out here. There's certain these crow feet they call them, right? They mean something, but it's a connection up here, and that connects down here to person roles, which also breaks it down to role, right? So it's just a further breakdown of that. But then you could have TV series, right? So you break it down. It's like a path, right? Okay, so this person was in this movie, but they're also in this TV show, right? Okay, well, how many seasons did that TV show have? Okay, because now you're in the world of the TV show. How many episodes are there, right? So that's why databases have to have specifics, so that way you can identify and you can tie them back, right? To the specific genre, to the specific platform, whether it's a movie, TV show. All right. So we talked about specifics, data, right? Primary and foreign keys. Okay, every table is going to have a primary key, right? A way you access that. The way they're called keys because you have to open it, right? Access. Think about it. There's a program called Microsoft Access, right? So we're talking about, um, and Ron's having some fond memories of databases back in the days. But you can be confusing, but the more you do it, it makes sense, and the more you get familiarize yourself with the database. But primary key in this case, we're talking about music, right? So you have recordings, right? You have an album ID that's just that album, right? But then you have the artist ID, right? Who worked on that recording, but they're part of a genre, right? Okay, well, genre has its own key that lives in genre, right? Oddly enough, and then artist ID over here you have it's an artist ID, but you also have those become foreign keys, okay? Although they're not your primary key, they're foreign keys that you can tie together, right? You can do joins and things like that when you have foreign keys. Okay, so you have the genre ID and the artist ID are primary keys in their own table, but they become foreign keys in the recording table. Okay, there's something called relationships. There's a one-to-many relationship, right? Because the foreign keys, in that case, there's a one-to-many, right? Because there's many tables that can be related to it, right? Now the foreign key, you can use it as a primary key only if it's connected by a one-to-one relationship, not a one-to-many, because that wouldn't work, right? Wouldn't make sense. So there might be some cases where you would want to do that if you're looking for a specific set of data. But if you can get away with just the primary key, there's no point in using a foreign key as a primary key unless you absolutely have to, right? If you have that one-to-one relationship. So that's just the way to think about it, right? One-to-one only relates to one table, whereas one-to-many is one to many different, there's different relationships going on, kind of like we saw in the movies, right? All right, 20. We talked a little bit about blobs, right? That's a data type, whereas something like miscellaneous is just a random set of data. You have numeric data, which could be a bit tiny integer. Sometimes you definitely have decimals, right? If it's a bank, you're definitely gonna have decimals. If you're dealing with scientific data, you're going to have float, right, which would be 0.00001 or something like that, right? Those are the different types of data. And if you go to the W3 Schools website, that kind of lists those out. Just so you understand that they're there for a reason, like the date have a timestamp or the year, right? You may not care about the year, you may just want the time. So that's why you'd specify that when you're building your database. Characters are important because you want to specify, I only want 45 characters, I only want 30 characters, right? Those kind of things. Unicode characters, those kind of things you only want to have specified because that way you know the limits of your character string, right? Unicodes like emojis don't work with Unicode, right? Those kind of things. Like you have to have a certain set of database specifications. Binary, var binary, you can set that the maximum. Those kind of different things that you can look up there. You don't really need to know extensive details about data types, just that they exist, right? Helps to know there's a reason for it. All right. So now let's get to the fun stuff. This is how they create a database in SQL. It's very simple. It's just create database and what you want to call it. All right. So if we go here, now they've already created some databases, right? But I'm just going to drop down here. We're not going to actually create a database, but I just want to show you an example. And let me know if you can see the screen okay. It might be, it's a little slow loading. I have a pretty good connection, but sometimes. Okay. So here, whoops, it jumped on me. So you're just creating the database, test database, right? That's an example. And it's real, that actually creates the database in whatever management system you're using. Not too much to that. Yeah, and W3 Schools is a website that we can kind of get your feet wet with database building, testing. We use it for examples here as we explain it. So drop database is a way to actually remove a database. So I'm just going to click on here so I can explain it to you. So drop database, be careful, like it says, deleting a database will result in the loss of complete information stored in that database. So unless you're sure, you're kind of wiping that database. In fact, that's what you're doing. You're totally dropping the bomb. Like, this is it. I don't want this anymore. Okay. You're going to wipe out that database. So use it sparingly, but you may use it if you're clearing something out, right? So you can see that on there. Okay, well, this is probably what you should have had done before, right? Backup database is used to create a full backup of an existing SQL database. And you'd find admins and people that are really concerned about their data would use this frequently. And they just go to a disk, wherever they want to store it. It might be even Amazon or on the cloud right now, right, somewhere. You would just say backup database to where you want it to back up to, right? Let's see if there's an example here. Excuse me, backup database. Taking a second to click. So yeah, same thing here. It's just backup database. Well, tell me what database name, right? Where do you want to save it, right? It could be on your partition somewhere. It just depends where. Like here's an example down here. He's saving it on D backups, then it's going to be .bak is the file. So that's good. You definitely want to back up your databases on a regular basis, on the regular. But in case you wipe it, you can always go back and get a backup, right? Alter DB, that just modifies the database. That's a little bit different than insert. You're actually making an alteration to your database. And as it loads here. So in this case, alter table, right? You're telling it, I want to do the table. We can actually do it here. In this case, we're looking at a database full of customers. So I want to show you, it's going to add the email field. So let's see right now, see if this database isn't quite showing up yet. Let's see here if it shows. Okay, well now there it goes, as we restored it. So now if you look here, what are we doing? If we look at customers, before we do this, I want to show you. Okay, can everyone see the screen clear here? Not the advertisement. Now you know I'm in Virginia, local ads. But there's customer ID, address, postal code. Do you see any email? There's not. There's not email. There's no email. So what we're gonna do is we're gonna alter that. We're gonna make that happen. Okay. How are we gonna do that? We are going to run SQL. Remember, SQL is how we communicate. So we're gonna say alter table, customers add email, right? And we're saying, okay, variable characters of 255. We can make it less. We can make it 10, but you want to have like a lot of space for emails. So they tend to be long, right? Once you start adding Gmail and Yahoo and all those big ones, right? So here we go. So now we've updated the customers. You don't see anything here. You may have seen just a little flash. But again, remember we did the call customers here. Now, if we run that again, so get in the habit of running SQL, select from, all from customers. Now we have email. Okay, so we altered that table. We didn't insert a record. That would be if insert record would be if we inserted data here, right here. We'll do that momentarily, but now we altered the table completely. Okay, we added something to it. All right, makes sense. Varchar means variable characters. It means you can have different. You're gonna have dots, right? You're gonna have letters, right? Because you're gonna have the at symbol, right? So you need those to be variable characters. There's a variation. Does that make sense? So you can't just say letters only. You have to be variable characters. All right. So create a table. Now, this is completely creating a new table. In this case, they just created customers, right? But we already have customers, right? So they're just giving you the syntax. Don't get too worried about that. They're just telling you need column 1, column 2. This is if you'd actually create it, you put your primary key, but in SQL, you just do something simple like this. Let me see if I can go back here and close these two out here. Okay, so we are going to, now we don't want to create a database, we just want to create a table. And we're going to use the example built in here. But this is the syntax, don't worry too much about that. So again, we don't have a persons table, right? We had customer and things like that. This is telling you right here, we're going to add, but we need to kind of give it some more data, right? We need to tell, okay, person ID, that's an integer, int. So it's going to be like a 1, a 2, a 3, right? Only. You can't, no letters, no symbols, no emojis, right? That'd be kind of a weird ID if you had emoji, but it has to be unique. Last name, again, variable characters. 255 is long. I don't know anybody with a last name of 255 characters, but just to be safe. Now, some people have multiple names, right? Like hyphenated and those things. So you might want some space, but 255 is a lot. First name is a lot too. You wouldn't need 255 as a limit, but they're doing it just to be safe. Okay, but we're telling it, you have to tell it, right? You have to say a data type. Okay, so create me a person table with last name, first name, address, and city. Okay, and y'all can follow along too if you're on SQL on the website. Simple enough. You just click there. Okay, and we're going to run SQL. Now notice no tables here for persons, right? As we run the database, the query, the command, right? We run it. We see that, guess what? It added persons. Well, there's no records in it yet, but what we might want to do is we might want to check it to see if, oh, I'm not trying to add it again. It got confused. It's like, what are you trying to do? There's no results now because we don't have any data, but if we were to put data in there, you would see that the columns. Okay, but we've definitely were able to create that table. So easy enough. 24. Okay. So alter table modifies a table, right? Add a columns, things you could drop a table. So just as easily as we added that one, we could just take it out, right? We'll be like, maybe I don't want to do that after all, right? Maybe I don't need persons because it sounds kind of weird, right? Like maybe peoples or human entities. That'd be a good one. Since I'm in outer space, I think I would have that one. The human entities table. Okay, we're gonna go ahead and delete. We're gonna drop that table. They said shippers, but I like shippers. I don't want to take out shippers. We need shippers. So let's go ahead and just easily modify the command here. And it may be a little slow there because shippers has data. I like data. I don't want to add more data if I don't have to. Drop is delete basically. So I didn't have it backed up, but there we go. Bye persons. Bye human persons. Okay. That's the easiest way to drop a table, right? If you made a mistake, you can delete it. No worries. Now, if you didn't have it backed up, I can't go back. I'd have to recreate it. We didn't have much data. Now, let's say we had a lot of data, right? That would be not good. Moving on. Update. Update is how we now update's a little bit different than alter. We're updating, we're modifying an existing record. That's the difference, okay? You're modifying an existing record, okay? And how you do that, you do that with the update command. And I'm just going to close these out so we don't have too many tabs open. But you're going to go to update, which is going to be here towards the top. There's a few different ones here, but the best examples here, right above delete. So just go to update. If you're learning along at home. Okay, so same thing. You just need update. Well, what do you want to update? The table name. Well, what do you want to set it to? I want to set it to this one, this column. What do you want that column to have? A certain value, right? So you got to be specific and where I want this to happen, right? Because if you don't, it's not going to know what to do, right? Because computers are very obedient, but you have to give them proper instructions. Otherwise, they don't know what to do. So in this case, we have customers, right? We want to set contact name. So right now, in this case, we want to change the contact name, right? So what we're going to do is we're going to update customers. We're going to set the contact name. We're just going to say Albert Schmidt, City of Frankfurt, right? And customer ID. So it's going to change. We're telling it to update. We're telling what we want to do. Okay, so it knows there's going to be a change. Set is where you want to set it, what you want to set it to, and then where is the ID. So there we go. Lickety split, right? We got the all from customers. Well, lo and behold, we have our contact name changed to Alfred Schmidt. Customer ID 1, right? If we would have put customer ID 2, it would have changed it down here. And we also changed the city. We could change the address. We could change the customer name. Anything here, we can do that. We can manipulate that data. We just got to put in the right kind of stuff, right? We got to put in the right expressions here. Set contact name. We could say a lot of different things, right? So there's a huge variety there. But in that example, that just changes number 1. Okay. So that's how you would update. Now we're going to talk about insert, right? We're going to insert brand new records, brand new, never been seen records, right? And we're going to do that by using the insert into command. And Vlad asked how this ties into testing. How this ties into testing? Well, there could be a lot of things. There could be changes on your website, and you'll see when we do testing of the on the practice on Thursday. You have to know how this stuff operates, right? In case you make a change, you want to test something, right? Maybe you want to change something in the database and see if it updates from your website, right? Or maybe there's something going on in your database you need to inspect, right? You need to know how to do SQL queries. So the more you understand about SQL and databases, the easier it'll be for you to test, right? You can test how it maps, right? Yeah, so you may not be doing SQL queries every day, but you'll definitely do them at some point if you're testing a website or some kind of data-driven thing, which is a lot of stuff. Okay, insert into. So this example, we want to insert. Now we don't have this record at all, right? Okay, pay attention to two things here. 91 records, right? We have 91 records, okay? 90 records on the wall. Okay, we have now this is showing you afterwards, but we're gonna change it. We're gonna insert into where customers. Okay, but you have to tell it the data, right? Customer name, contact name. You can leave this blank, one of these values, and it's just going to be null. But since we have all of Mr. Erickson's information, we want to update the customers, right? He has a name. We need to know Skagin 21, right? We need to know the address, the city, all that stuff. Since we have that, we're going to go ahead and try it ourselves. Okay, so remember 91 records. We're going to just simply run the SQL. And when we're done, we'll have 92 records, as you see there. Fascinating stuff, right? I know some people might be, it's the end of the day, right? Dinner time, those kind of things. Paint, paint drying, that works. Hey, good time to let the paint dry. So there it is. We inserted a record that was never there before, right, into that. Now, of course, we still have email null, right, because we never filled that out yet. Because we have all these null, everybody's null for email because we don't have their email yet. We don't want to spam them just yet, but we will. Oh, John was saying it's like watching paint dry. I would say it's more like watching water boil, right? Kind of getting warmer, it's bubbling up. Fun times. But yeah, you need to stuff you need to know though, right? It's just like part of the job, one of the tactical things, okay? So let's talk about the next type of thing here, which is delete. Now this is not deleting the entire table, you're deleting a record. That's why there's a difference between drop and delete. They have to make that distinction. Now you are deleting something when you do that, okay? So we're going to go here and we are going to delete some records. Now, why would you do this? Maybe you want to test that if you delete it in here, does it show up on the website, right? Is that connection there working, right? Just kind of like verification, right? You need to do those two things, but you need to know how to do that, right? If you're like, I don't know how to do a SQL query, someone's got to do it for me, right? Well, no, your value is, oh yeah, I can do that. I can do this, right? So the difference between drop and delete is drop. You can drop the entire table, right? You can drop the entire database, right? Where delete is more specific. It's like a backspace on your keyboard, right? So you can actually specify what you want to do. It's more specific. Does that make sense? No, there's not an undo button in SQL. I mean, there is in some of the you'll see in dbeaver and things like that. There's some options, but not necessarily undo. Not like Microsoft Word or something like that. Okay, but in this case, we're going to delete. You just have to tell it where and the condition. Okay, we're going to delete from customers where customer name is Alfred Futtergeist. Where does Alfred Futtergeist live? Remember he was number 1. Okay. So let's go ahead and try it ourselves. Delete from customers. Yep. Where customer name equals Alfred. What do you think is going to happen? Let's just try a little thing. Let's say I don't really know SQL, right? I'm like, I'm just going to put it like that. I just copy and paste it. I really don't know. Let's see what happens. Oh, I made changes to the database, but did it find it? It didn't, right? So they're lied to you, right? Said there was changes made, and you're like, oh, it's still here. I still see it, right? You have to be specific. It has to match. If there's not a match, it's not going to work. Okay. So we go back here. We just did a select all to find him. Let's go back here again and reopen it. And this time, let's just make sure to do it right? Because you're like, I took that SQL class with Mark, and I remembered he said it has to match. Otherwise, it's not going to work, right? Because there's no predictive nature of, like, when you type something, right? SQL doesn't know. It's very specific. So now, if I say, okay, I have Futtergeist in there, I know it has to be exact. Now it says the record's changed. Guess what? Oh, that's okay. We're just typing random stuff. It's for fun. So if I go to customers, guess what? Mr. Futtergeist. Oh yeah, I think it's Futtergeist. Is gone. Okay. We've essentially deleted that record from there, right? So now, but keep in mind now your ID is gone, right? It doesn't make Anna Trujillo business 2 number 1, right? She stays number 2. The ID is always going to be there. Now you could make a customer ID with 1. You could do that manually. You can add customer ID. You can add them back. If you did something like that, you could add all those values back, but you'd have to know how they line up. Okay. Does it make sense? All right. Yeah, definitely. Syntax is tricky. Yeah. So when you delete it, it deletes the row. So here it's not going to delete. It's not going to move up. Doesn't, like, Anna Trio doesn't get promoted to number 1. Okay, she stays number 2 on all that data, but the whole data on that row is gone completely from the database. Okay, now this is select. Select is very powerful. Now you will be doing a lot of select when you're looking for data, right? You're gonna have to find a way to find the data, not just select all. It's not always going to be select all. You want to select specifics, right? So there's ways to add on to that select. Okay, we've seen select all, right? We don't need to do that anymore. We've done that plenty of times. But let's say, for example, I just want to see customer name, and I just want to see city. From where? From customers. You have to tell it, right? You have to say what you want. So tell it what you want to see and where you want to see it from. Try it ourselves. All right. So you're selecting customer name and city, right? If I took out city, it would just be customer name. But in that case, we did a comma. So we see both of those, okay? So what do we see? Same database, right? But I've alienated everything else. All I see is customer name and city because I specified, right? We could take out, if I just wanted to see customers, like I said, we could do this. What do you think is going to happen? I'm just going to get the name, okay? A lot of names, a lot of customers. But if you know how to manipulate the data, you can do that, okay? We're going to learn more about how to specify that even further, okay? Because you get a lot of stuff back from that, right? So let me just make sure I didn't miss anything here for you on 28. because there's conditions, right? We're going to put some conditions like we did, right? We did select from where in those conditions. Now we can also do where not. There's an example. Let me see here if we have. I'm just looking for the where. Here we go. In the meantime, you get bombarded with ads from everything. Okay, so we're still talking about select, but we're saying where, right? We're gonna say not, right? See there's different options here. So we could say equal, greater than, or if you're dealing with a number. Between is a range. We'll learn about like in a little bit, right? But now we're gonna do not. So it tells you the example here. So let me see here. There's a couple different options here for that. But we're just going to give you if it's like a combination, right, of those different things. So we're not condition, right? Let's see if there's an example. If not, we'll just make it up. Okay, here's one, right? So this is process. The reason you would do this in testing is a process of elimination, right? You know Germany's not causing you trouble. Germany's good, right? They have good beer. They're not giving you trouble. So you're going to say, I'm going to eliminate Germany. I'm going to take them out of the equation, right? So we're going to run SQL because Mr. Federgeist was nice to us. And we're going to take them out. So we don't see, if you look at the page, I don't see any Germany on there. Anybody? Right? Okay, you see Mexico on the top there, right? So Victoria asked the question, when we are going to be working in the future, will we have the same website similar to this? No, probably not, but you'll have something similar, right? You'll have a way to access that data, which we'll learn like next Thursday, this coming Thursday, we'll learn about testing a database and making changes and actually see it happen. But this is more just for training purposes. You're welcome. So let's say we want to we took out Germany, right? Let's say we want to take out Mexico. Well, bye-bye, Mexico. Oh, yeah, I don't like the way UK is looking at me there. Bye-bye, UK. And then this comes up because it's just, we ran the query. Now, if I wanted to take out Mexico and UK, I'd have to do a combination of those two. In that case, you'd use an or. Okay. I'll show you an example here. So we said take out Germany. In this case, we could say we want only Germany or Spain, right? So in this case, we're not excluding, we're including it. We could put a not in there, but in this case, let's just run it and let's get these two. Okay, so what do we get? We get Germany or Spain, right? We selected it. We've eliminated everything else. So it's just how you think, right? Should I go in there and do a command for everything else, or it's a process of deduction, right? I only want to see these two, so let me just put an or statement, right? And you could do multiples in there, but for this training purposes, we're just doing those, all right? So select all from customers, right? If I wanted to see only maybe city, right? Then I would say select city from customers where those countries are there, right? And then it's going to give me all the cities that are country are Germany or Spain. that make sense? And then there's two questions from Vlad, or I'm sorry, Dimitri. Dimitri asked, can we exclude 2+ countries? Yeah, you can do more. An and an or are not really the same because it depends how you want to do. Because if I do and here, for example, to your question, oops, there is an and statement, but that would mean that's a different kind of condition, right? You see how that works? There's no country that is Germany and Spain, right? But there is, I'm just trying to from memory here. There's a city, for example, if I just wanted this city, Mannheim, right? If I knew Mannheim was my culprit, right? I could do something like this, right? Where let's just see all. Let's go back to change this all. And we're not the country, but the city equals Mannheim. And actually, I want to lowercase that. It'll work either way. Okay, what do we get? We get one record. Okay, because we said end. That creates a condition. There is a Mannheim, Germany, but again, to the inverse, this will give us, now this won't, this will, okay, let me ask you the question. Now, see if let's test your understanding. Do you think this is going to give me one record or multiple records? If I do a or with the city and the country. Okay. All right. So it sounds like everybody understands. Yep. Okay. Cool. Good. That's a good gauge of understanding because there's going to be uh, multiples, right? Germany, multiple cities. So could be a Mannheim, England, right? Could be a Mannheim, something else, right? With the country. In this case, it is just um, that. But to my point, if I put what was another city in there? I want something that's easy to spell. All right. I like Madrid. I like that. I like my odds with that one. That's easy to spell. Oh, come on. I gotta close some of these tabs. There's too many requests going on and it gets slow. All right. So now, so we know Mannheim is in Germany, right? So we're gonna get everything from Germany. But there's no such thing as an MM Madrid. There's only Madrid. So we're saying now where the country is Germany, so we'll get everything from Germany and we'll just get cities that have Madrid. Okay. So now we get Germany and Spain, right? Because Madrid is in Spain and there's multiple Madrids, right? So does that make sense? Kind of cool, right? I mean, it's not going to change the world, but it's interesting. All right. So that kind of breaks down. I think that is a good breakdown of the end, the or, the knots. We untied all the knots. Wah, wah. All right. And Ksenia is asking when you have to use the tick marks. They're called tick marks or quotations. You use those anytime you use a string literal when you want to specify something like a customer name or city. If you don't, it doesn't know, right? Give me 1 second here. I'm gonna get out of these so we won't lose the SQL's becoming a little unresponsive. We'll check the pulse, get it back. So you'd use those to make sure that you're yeah, anything that has names, right? Like you wouldn't do it for postal code necessarily because it's a number, but when you're dealing with literals like strings, you would. All right, so we talked about multiple conditions and end. You're welcome. Now let's talk about operators like, like, does anybody know like the teenage girls when they go to the mall, they're like, it's kind of like this, like to have that? Well, it's the same thing. It's it's a like operator, right? It's similar to, right? And I'll take you to that example here. Once my slides stop wigging out. All right, so let's get out of this one. Let's see here. Let's go back to. Let's just go back to W3 Schools Home. It'll take us to the columns where we can select. So we have like is pretty cool because it gives us some options to do similarities. Okay, so similarities in the way things appear. And close everything, so it should pop up here. And you do this if you only do like a pattern that you're looking for, right? So here's some examples where customer name like A, and you have to use, which you all notice percentage sign, but if you know anything about like programming or calculators, it's the modulus, right? The remainder. But anyway, that's why that's there. So it's not really percentage. Think about it like remainder, right? A and the remainder, right? Any values that start with A. If you put the modulus in front of the A, find any values that end with A, or in the middle, right? In this case, OR, any position. Now, but if you put the underscore, it's telling it specifically the second position, right? When you put that, if you put the other underscore here, it's the least 2 characters in length, right? So it just depends where you position it, right? In this example, we're going to do some stuff here for A. This is everything that ends. I'm sorry. This is everything that begins with A because the modulus is after the A. Okay, so let's run the SQL. And what do we get? We get everybody that begins with A. Same thing, just for posterity's sake to understand the difference. What if we do B? Oh, what do we get? We get B, right? So pretty cool, right? So once you know the commands, you can tell it, show me everything that starts with B. By the same token, you're not going to probably have, just the way the languages work, you're probably not going to have things that end with B, but you're going to have most likely stuff that ends with D, as you see a couple here. You see one, right? So now I put the modulus in front of D, so everything that ends in D, right? We have a couple. Drakenblut Dickinson and Frankenvarsen, customer name. And so that's the customers, right? Customer's name. Or I'm sorry, select all from customers. So anything that with the customer name, right? Now, if I said contact name, would be different. Well, there's actually one that ends in B there, right? So you specify that data there. What's another one? Okay, let's try the one with the OR in the middle, right? Is everyone doing okay? Still awake? Do I need to get the bullhorn out? That'd probably wake me up too. I'd be like, select all from customers, where customer name like modulus OR, right? In the middle. Uh-oh, caffeine and Adderall. I don't know if that's a good combination, Lola. Maybe it is. I had some of my caffeine this morning. So you have select all from customers, where customer name like OR. So you see that there? We're talking about just customer name. Now, if we said contact name, we get different results. I want to do that for you. Okay, so we get fewer names because we shifted to contact name, right? So there's Moreno, right? There's OR Ashworth, right? Ascorti, Yores. So you see the power of SQL query. You can there's a lot of versatility here because you're basically getting all this data and it's very responsive. All right. Select all from customers where customer name like. Now this is the underscore, right? So that specific position there. And I'm going to have some of my sparkling water. No caffeine, just water. Select all from customers where customer name like underscore R. Underscore R. So that gives you that position there. Now we said customer name, right? So don't forget about this part on the right. Just look on the left. AR, DR, ER, FR, GR, PR. I don't know. That's pretty fascinating. We can go through all that and the computer's like, boom, there it is. Now, if we want to do another position, we could do, let's see if this works. Okay, you notice that? It's kind of like, have you ever played Hangman? You just kind of keep on going down the line until it shows up. So there we go. All right, easy. What that's called is that's called plug and play, where I already have a command. I'm just going to plug in what I want to see, right? Same thing. If I wanted to do, okay, say I didn't really say I was more concerned about, say I was getting a lot of countries, right? With that, you're probably not going to find any there with that, but we saw Brazil, right? Was there as an example? Oh, France, Brazil. So, and then, no, Miriam asked, do we need to include a space between each tag in query? Are you referring to, let me find the command here. So you're talking about like space between, like if I did, this wouldn't work. You see that, what that happened? Because I didn't have the space. So, but I will tell you this, now these have to be pretty precise, but if you don't like going caps all the time, you don't need to capitalize. This will do the same. What about camel case? Now I wonder. That might work just for fun. It still works. So it's not that specific. And then accented characters. That's a good question. Sorry, Deemtra asked a question. Do numbers work like this where address like to? It depends. If we do, what's the best way to do it is just to find out and test it out, right? So I think it functions a little differently, but whoops, contains it too. It's basically just looking at it like string literal, right? What if we did, and this is powerful if you have like a bunch of data. So there you go. So to answer, I gotta be honest with you, I wasn't 100% sure about that. So I was like, oh man, I rolled the dice on that one. I'm like, let's try this out. No, it's like, so you have characters, as long as it falls in that, you make sure you have your tick marks in there. And then JP was asking about some good questions here about the accents, right? That's a good question. I'm pretty sure it does actually, because, but if I just do, actually, let's just do modulus. If I just do E here, it's going to give me a bunch of these, right? But I'm like, I don't know about that. I just want to see the accent. I just want to see Mexico with the E, right? There you go. But that gives you address though. Now, if I said city, was it city? Then it would give us Mexico. I know Mexico. I've been there a few times, so I could say it. Yep. And then Montreal, obviously. Montreal is right there with the accent. So yeah, so it does do that. In case sensitive, not so much. You'd still pull up everything with the E in there. So not specifically. Yeah, you could use multiple letters. You could do something like that. But it's probably won't get anything there because it's going to be whoops. But you would do something like that. Is that what you're asking, Ariane? Yep. So you can do multiple letters. And then Miriam asked, do people pay money to store their websites data in databases? Absolutely. They pay a lot of money. That's what some of the biggest money makers is storing data. Like yeah, you'd be surprised. Okay, so JP asked, what if I want to select something with modulus like an interest rate? Okay, for example, that's actually a good question. You'd have to just use the tick marks, right? You'd have to specify. We don't have all caps. So hold on one second. So I was shouting. DevOps creating databases. No, DevOps typically don't work on databases. You have a DB admin, database admin. But that's a great question. And honestly, we don't really have an example in the database to show that, but you'd most likely put like tick mark. They're called escape characters, but we don't go over that too much here. But you'd have something like that. So a testing example using SQL. This is what we're doing. We're going through the database and we're making changes and we're testing to see if it shows up. That's what you would do when we go next week on the website. We'll test more of that, and you'll see that on Thursday. So, but yeah, this is more like just accessing the database and manipulating. But test an example would be like I add my information on the website. Does it show up in the database? We'll do more of that on Thursday. All right, so let's keep going because we've got a few more things to cover. Okay, so distinct gives you like distinctions, right? And that's just means a select distinct. Give me a specific information, right? Okay, so distinct. Okay, in this case, we're just selecting distinct country from customers. So that means give us unique. Don't show me multiples, right? That's what that means. So if I say select, whoops, I think it gave me the wrong one. But for example, here, just to show you, right, we see multiples, right? We see a lot of differences there, right? Whereas if I say select distinct, and even just so I don't have to open up a new tab, I can just copy the SQL, right? That's a nice thing about. Let me close out some of these so we don't get W3 schools mad at us. The servers. Okay, so now look at the difference, right? You see all them all here? There you go. We see only individuals. There's a lot of different records for Mexico, but let's say I don't really care about the multiples. I just want to know what countries we're working with, right? That's when you would use distinct, when you want to isolate. All right. We got quite a few slides to get making some progress, but I want to make sure you have. We did where or not in combinations and or we did that, so we don't need to repeat that again. Partial match like now this is, for example, it's kind of like shorthand, right? Where between is like that. We can use an example of that real quick. Let me show you here. So between is kind of giving you like a range, so to speak, right? So this is we deal with some numbers here, not necessarily percentages like JP was asking, but you do with numbers. And we're saying give me a range, right? So that's where you kind of specify that. So it's going to give you everything between 10 and 20, where price, right? So 18, right? All the way to 13, 20. Now they're not sorted, but you can do that. There's a couple different ways you can do that, which we'll learn, but you just saw the range there. If we did order ascending by descending, right? Well, that's how you could do that. Let's look at where in real quick. Where in's going to tell you kind of similar to that, but you're going to use an in statement, right? Combination with the where, right? So select all from customers where country in. So it's kind of like the countries, but you can do multiples, right? So that's kind of a nice thing with this. Okay. And if it's going a little speedier, because sorry, if it goes slow, we don't have enough time for everything. So sorry, but the ones that think I'm going too fast, but we have to we're time box. So look at that. We get Germany, France, UK, right? We said we're in. So that's a way to kind of filter out, right? It's kind of similar to the like, but you're a little more specific. Okay, now talking about order by. That's how we can do descending it. Remember the prices, right? We can do order by command. And all we're selling it is giving us ascending, descending, right? A certain way, right? Because we're going to order by the country, but we're going to tell it to be descending. Okay. So we can just simply, we can copy the code here and come over to our editor so we don't have multiple tabs open. But we're going to say, come on, man. Sorry. My MacBook's trustling here. Okay, so descending, right? Okay. Well, what's the opposite of descending? It's ascending. I think it's ACS. It might be. Yep. So you see that? Country, Argentina on top, A, B, C, D, E, F, G. So that's one thing you can use to do ascending. You can also do it with a couple different things. All right. So that's the way to order your values. We'll do some more of that on our practice on Thursday. Okay. Now union is when you join two or more sets, right? So unions are kind of important. Let's see if we can find an example here. We're saying to unify these tables, okay? Okay, let's see if we get to union. All right. So we're using suppliers and customers here, right? And we're going to order by city. So so we're getting a little more advanced in the SQL commands, but that's okay. There's plenty of examples here. So we're selecting city from customers, we're union, right? We're combining that select city from suppliers, right? So we're unifying those two tables and we're ordering it by city. So all we're going to get is city, but when we do that, we're combining customers and suppliers and the cities, right? We're union. It's not a join, but it's unionized, right? We're joining the union of those together. And that's just a way to join those, right? This is just more numbers. Select min, max, top. About prices, you could do that. It's just they're all kind of similar, just like sum, count, average. Okay, here's an example, right? Got a habit of clicking the try for yourself, and we could just copy it. Let's see. Okay, so we're saying select the minimum price, and we're just selling it as an alias. We're saying call it smallest price. I could say anything. I could say cheapest or cheap, right? It changes that alias. So that's the minimum price. That's the cheapest, right? 250. That's just another option of min. I could say max, right? As expensive, inflated, right? And it's going to say $263.50, whatever that is, right? So that's just a way to do that. It's just the alias. You can make that whatever you want it to be the as. Okay, now we need to talk about joins. So that's why I have to speed through these because that's just numbers. So, okay, joins can be confusing. Don't be afraid. You're just joining. I don't know if any of you ever worked with Venn diagrams, but an inner join just joins these in the middle where they intersect. So let's say you have customers and suppliers, right? You're just joining that data that kind of matches in the middle, right? Not on the left or the right outside of that. Whereas a full join, you just join everything. It's almost like a union of everything. I was just telling you more about joins here. Sorry, 1 second. Let me go back because we're running out of time here. But just look up the on the slide, the presentation, study the diagrams. You have left join, which is just the data on the left, right? And the intersecting data in the middle, which would be the inner. So it's like an inner join and a left join. But you everything on the outside of that table that doesn't match, you don't want that, right? Whereas a right join, you said, give me everything here, but not everything on the left. So the best way to do it is just to give you an example. That's really the only option, right? So talking about joins, right? So we have two tables here, right? Order ID and customer ID, right? So you can't get those independently, so you have to join them. So in this case, you have to say select orders.order ID, right? Because you have to tell it where you want it from, right? And you have to specify customers, customer name, orders.order date, right? So you always have to specify what you want from that table, right? And where you're pulling this from, you're pulling it from orders, right? And we're going to do a join of customers on orders.customer ID and customers where it's the same. Does that make sense? Right? Equals means the same, right? So we're customer ID and orders.customer ID. So the same. That's your keys, right? So you'll learn more about that when we do more practice, okay? So we do that. We're going to run the SQL. And the only way to get this stuff is to practice, 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 right? But you see we have the order ID, right? Because we asked for that on the top, right? Orders.order ID. We asked for the customer name from customers. We get that. But we also asked for the order date. Here we go. We have the order date, right? And we're getting this all from where? The orders table, if you see on the right here, right? You say from, you could say from a different table, but you'd have to know what's in there. Inner join, right? Where there's a match. Customer ID. Remember the inner join in the middle, the Venn diagram where those all match. So it's really a lot of information. It's tough to, you have to practice. That's the only way you're going to get that stuff. And the watching these slides doesn't really help you, right? I mean, I gotta be honest with you, it doesn't help. It just shows you where it matches, right, on the inner side. A full outer join, right? That's basically joining everything. Okay. So so I would suggest in your free time, if you have, I know we're all busy, right? But go through here, go through the joins, study the tables a little bit. When we go to full join, we're going to join everything, right? Those two tables, we're just saying, just combine everything from, but you have to tell it where, right? So in this case, select customer name, orders ID, kind of like we did before, from customers this time, right? Now we're not going to orders, we're going to customers, and we're doing a full join. and we're joining, it's an outer join, right? So we're joining everything, right? So if I come here, it's going to kind of like we did here, but it's going to be an outer join. So that means that's everything, right? So where that matches. See that? Customer ID equals orders.customer ID. Oh, well, so it gives you the command, but it could not. Full outer joins are not currently supported, but that's how you would do it. But in this example, it doesn't do it justice, but they need to update their website. So the full join is going to join everything there. So it's like suggest just practicing with those. Yeah, there's a lot of we do more joins in the actual lesson. So right join, same thing. Then look at the tables here. You have this is before we talk about your homework. So you have right outer join, you have customer ID on the right side, right? You're joining that on the customer ID with customers, right? So you're actually showing the related orders only. Does that make sense? So related, we have a couple minutes to do that real quick. So let's do a right join. This one should work. And yeah, see, you can't, there's a lot in SQL. You can't have the whole W3C certification in an hour and a half class, right? So I recommend just getting here and just doing as much practice as you can. So there's an example here, right? A right join. And we're gonna copy that. Yeah, and then asking about substitute. No, you have to tell join. If you don't tell it join, it's not gonna know. So you can't substitute the dots. You have to have Victoria to answer your question. But good question. But yeah, there's not too many. There's shortcuts, but not many. So what we did is we just joined where we just asked for order ID only, right? We asked for the last name and the first name, right? The employees, we got it from the orders table, and we said on the right side of the right join, right? We said order employee ID and order ID. That's where there's a match, right? That's what that means. The on means where there's a match. You see that equals there? So where employee ID from orders matches employee ID and employees, and then we just want to order it by order ID, right? So really, it's not something you can just get in an hour and a half. It's a lot. So, but that's a good intro, good crash course. Okay. So your homework. Okay, we're done. You survived SQL intro, and I've survived. I'm going to go back down to Earth in my spaceship, my rocket. Install. There's instructions on LMS for installing dbeaver, right? You follow those instructions carefully. Go to the website. I already have it. I actually don't have it installed on here, so I got to go through the process and reinstall it here. But there it is. It's free. It's lightweight. You just download it. And there's installations for Mac, installation for Windows. Some of you have Mac, some of you have Windows. But just go to there's instructions on LMS how to do it. But you want to get the community. Hey, we're done with you. They want W3 wanted to make a comeback. It's like, I want to be in the limelight. Get out of here. Sorry about that. Community edition, that's the free one. Okay. You don't enterprise, you do not want. No, it doesn't take a lot of space. It's very small. In fact, I think it's like in the megabytes, not like 100 gigabytes. Okay. So there's your install. There's instructions about the passwords and all that you need. So you need to install that. If you have any trouble, jump on the support channel. But basically, you just follow the instructions. Hey, John, thanks. I appreciate that. John said, best SQL course, bruh. I took one in dev school and they can't touch you. Great job. Appreciate it. Yeah. It's a lot to learn, though. So if people haven't touched on it, but I would try to make it somewhat interesting, but it's It's a lot, but we're going to get more practice with Beaver. So please just download it, install it. There's passwords are inside the LMS, the guide sheet. Try to connect to the database. Make sure you follow the instructions word for word. Hope because the less time we have to troubleshoot, more time we can just jump in. So please try to do that before Thursday. Okay, I look forward to seeing everybody on Thursday. Do your practice. Thanks, Ronald. I appreciate that. And that's coming from some former developers. So they came over to the dark side, the light side, I should say. Thank you so much, everybody. It's been a pleasure. And remember, you can go back, you can slow me down if you want to. You can speed me up if you have to, whatever you have to do. You can cut me out completely, but enjoy. Everyone have a good night and practice, and make sure to do the surveys, please. I appreciate that. And you all have a lovely evening. Good night. Signing off from outer space. I won't be in outer space next time, to let you know. So thank you so much. Okay, I'm ending webinar for all. Your last chance to do an emoji.